Close your eyes and imagine an object in your hand that has no weight, no mass, and no physical burden whatsoever. A completely free entity. According to the laws of physics, if you give an object with zero mass even a tiny spark of energy, you would expect it to accelerate to infinite speed. After all, there is no matter ahead to slow it down, hold it back, or offer any resistance. This is exactly how light is built. The photons that make up light have zero rest mass. They are the freest particles in the entire universe. Yet the cosmos imposes a strange, rigid, and completely unbreakable speed limit on this ultimate freedom. Exactly 299,792 kilometers per second. Why not any faster? Why isn't it infinite? Why does light, which weighs absolutely nothing, slam into a wall and stop at this specific number instead of reaching, say, an even 300,000 kilometers per second? Who built this invisible barrier in front of light, and why? Today we are diving into one of the most fascinating and mind-bending questions of modern physics. And let's clear something up right from the start. The answer to this question isn't actually hidden within light itself. The answer lies within the very fabric of the reality we live in the nature of space and time. So let's discard what we think we know and begin this profound journey. Before we dive into the deep end, we need to understand how speed works in our everyday world and clear up a massive, very common misconception. When people hear Albert Einstein's famous concept that an object's mass increases as it speeds up, most immediately think, wait, so if I run incredibly fast, will I weigh more on a scale? Does the number of atoms inside me magically multiply? No, that is absolutely not what happens. Instead, think of this mass increase as the resistance the universe puts up against your movement. Whenever you want to speed something up, you have to add energy. In everyday life, that energy translates directly into more speed. But as an object approaches the speed of light, something strange happens. The extra energy you keep adding stops contributing significantly to its speed. Instead, more and more of that energy goes into increasing the object's resistance to further acceleration. Imagine you are pushing a lightweight shopping cart. As the cart gains speed, it begins to feel heavier, as if someone is secretly dropping invisible bricks into it. By the time you reach 90% of the speed of light, that once lightweight cart has become as sluggish and unyielding as a massive planet. To speed it up even a tiny bit more, you would need the energy output of an entire star. And if you somehow pushed it to 99.999% of the speed of light, the cart becomes so overwhelmingly heavy to move that even if you gathered all the energy in the entire universe, it still wouldn't be enough to accelerate it by a single millimeter per second. This is exactly why nothing in the universe with even a fraction of mass, even something as microscopic as the tip of a needle, can ever reach the speed of light. The cosmic border is permanently closed to anything made of matter. So how does light manage to breeze right through this border checkpoint? Because photons carry no rest mass at all. From the very moment photons are born, they merge directly into the highest speed lane of the universe. Furthermore, light doesn't start from zero and gradually accelerate by stepping on a gas pedal. When you switch on a flashlight, the emerging photons are already traveling at this maximum speed within the very first millisecond of their existence. Light is born moving at its cosmic limit, but this is where the real mystery begins. If light has no mass and experiences none of the limitations that affect ordinary matter, why doesn't it travel infinitely fast? Why doesn't it cross the entire universe instantly? Now we arrive at the heart of the question. Here is the key idea that changes everything. The speed of light is not really a speed limit for light. It is the speed limit of the universe itself. More specifically, it is the maximum speed at which information, influence, or cause and effect relationships can propagate through space-time. Physicists refer to this as the speed of causality. Imagine for a moment that the universe is a gigantic and perfectly functioning computer simulation. Every simulation has limits. It has a processor, an update rate, and a maximum amount of information it can handle. In a video game, your character can only move as fast as the game engine allows. No matter how powerful your character becomes, it cannot exceed the limits built into the system itself. The speed of light appears to be something similar. It represents the fastest rate at which the universe can transmit information from one location to another. Imagine that at this exact fleeting second, the sun suddenly vanishes without a trace. Let's say a rogue black hole swallows the sun instantly. When would we, here on Earth, notice that the sun is gone? Would the sky go dark the very same second? The answer is a resounding no. If the sun vanished right now, we on Earth would continue to see it shining in the sky and continue to feel its warmth for exactly 8 minutes and 20 seconds, as if nothing happened. In fact, here is an even wilder thought. The immense gravitational pull keeping Earth in its orbit wouldn't vanish instantly either. For those 8 minutes and 20 seconds, Earth would continue to orbit a ghost, a star that no longer exists. Only when that timer runs out would we be plunged into pitch blackness and flung out into the deep void of space in a straight line. Why? Because absolutely nothing in this universe, including gravitational waves and light itself, can travel faster than 299,792 kilometers per second. The information that an event has occurred cannot propagate through the fabric of reality any faster than this limit. Now let's take the idea one step further. What would happen if something could exceed the speed of light? Why does the universe enforce this limit so strictly? According to our current understanding of physics, faster than light travel would lead to something far more profound than simply moving quickly. It would lead to violations of causality. In other words, it would allow effects to occur before their causes. Imagine lighting a match. Normally, the sequence is simple. First, you strike the match. Then the flame appears. Cause comes first. Effect comes second. This ordering is one of the most fundamental principles of reality. But if information could travel faster than light, that order could break down. You could observe the result of an action before the action itself occurred. You might receive a message before it was sent. You might witness an event before its cause existed. In some reference frames, faster than light communication would effectively become communication backward in time. And that's where the real problem begins. The universe depends on a consistent chain of cause and effect. Without it, paradoxes would emerge everywhere. The logical structure of reality would begin to unravel. The speed limit imposed by space-time acts as a safeguard. It protects the universe from contradictions. It ensures that causes precede effects. Without that protection, the orderly universe we experience could not exist. To wrap it all up, light travels incredibly fast because it is completely massless, but it cannot go any faster because the barrier blocking its way isn't its own weight. It is the physical limitation of the space-time fabric it travels through. Light isn't slow. Our universe's framework simply doesn't allow for a faster flow of information. And this reality opens up a breathtaking perspective. When you look up at the stars in the night sky, you aren't seeing what those stars look like right now. You're looking at how they looked thousands or even millions of years ago. It is entirely possible that a star you are admiring in the sky right now actually exploded and died 1,000 years ago. But the information of its destruction is still traveling through the dark, and its final light is still on its way to us. Ultimately, the speed of light might seem like the universe's ultimate cage, but it is also a cosmic time machine that allows us to look directly into history every single time we look up at the cosmos. What do you think? Will humanity ever find a way to warp the fabric of space-time, hack the system, and manipulate this rigid hardware rule of the universe? Or is this speed limit an absolute, unbreachable prison wall meant to keep us contained inside the simulation? Let me know your thoughts in the comments below. If you enjoyed this deep dive into the cosmos, don't forget to hit the like button and subscribe to the channel so you never miss our next journey into the unknown. I'll see you in the next video in another mysterious corner of the universe.